Welcome to LNP Renewable System. Today we are going to discuss some of the basics of the electric vehicle, part 13. So if you have missed out part 1 to 12, no issue. Please subscribe to the channel and press the bell icon. Please share to everybody. Okay, so when you get it to your channel, in our channel we had created a playlist for all the 12 parts which I had already discussed. We have split this session into 25 parts. So each and every part will be a useful session, an engaging session. Come, let's get into the session. So, and in our discussions we might be using so many short forms in the descriptions. So if you have any doubt with the abbreviations that we are using, please refer to it. So what are the things that we are going to discuss today in this part? First thing is that we are going to study the efficiency curve between the induction motor and permanent magnet synchronous motor. Okay, and what are the influence of a rated voltage in an electrical vehicle? Okay, and what is this switched reluctance motor? How the switched reluctance motor work? And what are the characteristics of the switched reluctance motor? And what are the challenges in the switched reluctance motor? How to overcome the losses in the switched reluctance motor? And how the efficiency curve of a switched reluctance motor and a permanent magnet synchronous motor looks like. So if we get into the efficiency map, okay, so when compared with the induction motor, the permanent synchronous motor has a pretty good efficiency. If we draw a waveform between the RPM and the torque, it has a pretty good features. And if we try to compare, okay, to know the influence of a rated voltage in the electric vehicle, see here we have a speed and a power. So we have different conditions. Okay, so when the voltage was at 200 volt, so see the curve, so it's try to achieve the maximum and try to maintain the consistency. It's getting reduced with 200 voltage. When we increase the voltage to 300, see here again there is improvement in the curve. And when we keep on increasing the voltage to 700 voltage, there is a peak. It is trying to achieve the maximum peak and try to come to the minimum position. It means that so the power is keep on increasing when we increase the voltage, so that it is trying to achieve the maximum peak power during the different RPM speeds. Okay, the same thing if you try to see the speed torque characteristic. Okay, it is trying to maintain the consistency for a particular RPM. After that, it is trying to get reduced if the voltage is very less. When we try to improve our voltage from 200 volt to 700 volt, see here it is maintaining the consistency up to 4000 RPM. After that, it is trying to get reduced. So here the voltage plays an important role in influencing the characteristic of the waveform. So what is the switched reluctance motor? Switched reluctance motor is nothing but a device or a motor which has a shaft, which has a rotor, and which has a stator. Okay, and see here these are the armature windings. So when we try to look into the entire working operation, see here reluctance. What is so? Before trying to get depth into the switched reluctance, we should know what is reluctance. Reluctance is nothing but a magnetic property. Okay, so when the magnetic circuit, when it opposes the magnetic lines, it creates a force. That force is known as reluctance. Okay, so this switched reluctance motor works on the principle of magnetic reluctance. Okay, and what are the advantages and what are the key benefits of using this switched reluctance motor? Because its construction is very simple and robust. There is no permanent magnets. It has a very high efficiency and material cost is very less, and it has a very safest operation during no induced voltage is created without excitation. Okay, no short through the failures. And what is the principle of operation of this? See here, the rotor will get aligned when a diametrically opposite stator poles are excited. So what is happening in a magnetic circuit? The rotor, okay, prefers to come to the minimum reluctance position at an instant of excitation. When two rotor poles are aligned to two stator poles, okay, another set of rotor poles is out of alignment with respect to the different set of stator poles. Then because of it, what is happening? This set of stator pole is excited to bring the rotor poles into alignment. Likewise, sequentially switching the current into a stator windings, the rotor is rotated. Okay, the movement of the rotor is the production of because of torque and the power, which involves switching of current into stator windings where there is a variation of reluctance. So when we try to draw the graph of this switched reluctance motor characteristic, when you try to draw the graph between the speed and the torque, so the torque is trying to achieve the maximum position. After a particular speed, it is trying to maintain a constant power, and after that it is trying to fall. Okay, and when we try to draw the graph between the current and the flux, same like hysteresis loop, the graph waveforms will get established in the switched reluctance motor. And what are the challenges in the switched reluctance motor? So control is little complex. Okay, we have a torque ripple formation, and there is a possibility for acoustic noise to create. Okay, and we need have a better optimization for NVH. Okay, see, in the switched reluctance motor, we have so many possibilities for the losses. Okay, in order to reduce it, we are using some of the general techniques to reduce it. Say, for example, you want to reduce iron losses, we must be invest in the laminating the materials properly. In order to reduce the copper losses, first thing is that we need to do the simulation of the proximity losses and the skin effects. Second thing is that if there is a better trade-off between a cost and reliability for the bearings, innovation oil lubrication techniques we need to use, and we need to have a high precision bearing to avoid it. Okay, and in order to have a hollow shaft, allow the providing oil to the bearing opposite to the transmission. Okay, and in order to increase the strictness of the rotor construction simulation, okay, to find it, so maximum shaft diameter without a negative impact on the magnetic performance. And you can use the stator potting methods because it provides a consistent quality and fixes the windings into winding slots properly. So when we draw the efficiency characteristic, this is a real example of a switched reluctance motor and the permanent magnet synchronous motor. So as you can see here, permanent magnet synchronous motor is pretty good, okay, when compared to this switched reluctance motor. And when we get into the final summary of different electrical traction motors which is being used for our electrical traction purpose, this our induction motor. Okay, induction motor, when we get into the induction motor, it is only good for the high speed efficiency only it is having. The synchronous reluctance motor also has a very good efficiency. Okay, but when we have a low cost capabilities, synchronous rotor is very low cost, and switched reluctance is also a low cost one. Okay, so cost wise switched reluctance is better, but when the efficiency wise, induction motor and switched reluctance are pretty good. Okay, thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. We have covered the contact details in it. And if you are electrical and electronic engineering background, or if you are from electronic and communication background, or if you are from electronic instrumentation background, you want to get into the automation industry and you want to know the PLC programming, then you can contact us. We have provided the contact details here. We are providing Siemens, Allen Bradley, Delta PLC trainings along with the certification. You can contact us. And if you had a plan to work in the GCC countries, in order to work in the building management system or building automation and control system, you need to be pretty aware of the certain basic things. So we are providing the training on it, and we are also providing the certifications. It will be a useful certification for you. The sessions are going to be very useful sessions. Okay, and for solar on-grid, off-grid, hybrid applications, we are providing design, installation, testing, commissioning, consultancy, and training supports. Okay, and if you had a plan to establish a fencing for your agriculture farms, we are providing solar fencing kits, so you can contact us. We can supply you. And if you had a plan to establish a diesel IT system for your factories where the EV power is not available, then you can contact us. We have provided the contact details here. Thank you so much.